And it is time for yet another demo. And this time I checked my audio levels and did a test recording. So hopefully this is audible without having to blast the speakers and then forget that you did and blast your ears on the next thing you watch. So what do I have new this week? It is a sequencing engine. So this is JSON configuration for it, and it is basically just a generic state machine, and then in each state can be a timed sequence of commands and actions. So stuff like toggle valves, toggle controls, set analog outputs. There are conditional transitions, and if you wanted just time-based sequencing, you could just have one state with just a bunch of time entries, or like a startup and then a run and then a shutdown, whatever the case is. Pretty flexible system. Currently, I'm got it hard coded at 100 hertz loop rate, and that'll be a little bit configurable in the future. But mainly intending for this to run on C-Rios at the moment, so that's my first target. And this is going to run GSE for rocket engine test stands and structure test stands down the road. But I've got this right now. I don't have all of the communication up for making this work, so I'm doing it manually in the GUI. So this is the module for the sequencing engine, and it has commands for handling loads and starts. And right now I'm just doing that via its front panel. I've got it set to show and run for this initial development until I get all of the HTTP requests and everything else set up and working. Additionally, with this setup, if we take a look in the rest of the system config, I've added these 3 simulated software variable channels so that we can have a value we can poke as the process value that's looked at for this sequencing, and then 2, I'm going to call them output channels, so we can tell what mode it's in our GUI. And in the real world, these would be tied to heater enable or cooling enable. So what this little state machine is doing is bottle conditioning. So aiming at 800 psi. If you get up to 850, turn on a cooler until it gets back down to 800. If you get down to 750, turn on a heater until it gets back up to 800. So I can load this sequence, and we're going to see I've got a whole bunch of stuff that is show and run, so I can debug. We've got a top-level VI that ran asynchronously. This is the main loop for the sequence that was loaded. And then each of the states gets its own asynchronous loop. So the stop state, the start heat state, start cool state, start, hold, heat, and cool. So kind of a whole bunch of stuff got opened for me to be able to debug things as I've been getting this working, but we don't need them open. I'm going to go ahead and close them. We do need a GUI application running, so I can update the process value. Okay, so good config match. But now what I can do is change this, and nothing happens because I forgot to run the sequence. So I'm going to start the sequence, and we could see it went into heat mode because we're below 750 psi. So I'm going to go from 700 to 900 just so we can see it a little bit better. And as soon as I get to 800, it goes into a hold. So if it were to keep climbing, once it got to 850, it would go into cool, turns off. If I go back up to 850, cool turns on again, and go back down to 750, back up to 800. So a pretty neat little sequencing engine here. Relatively straightforward config. So there's the sequence, there's some entry information, some metadata for it. So what its display name would be in GUIs once I get all that glued together, some comments for editors, what its entry and abort states will be. Aborts aren't properly handled. I'm not actually using the entry configuration yet. I'm going to be adding that in. Right now, it's just hard coded to start with the start, whatever state is named to start. But on this one, as soon as the sequence starts running, it's going to make sure both of the conditioning controls are turned off, and that's going to transition into the hold state. The hold state's entire deal is there's no commands, so there's no steps, there's nothing timed or any controls being done. This is just checking to see if it needs to transition into starting to cool or starting to heat. So these are some conditional transitions. You can have any or all for the logic type, and then, of course, there could be several conditions being looked at. This is a very minimal, simple example. But if the pressure were to get high, so we've got a high limit, low limit, there's an out of range condition, there's timing conditions, so you could automatically transition if the sequence time gets to a certain length or the state you're in gets to a certain runtime. All of that is there for transitioning to different states. So if this were to trip, we go above 850, we're going to go to the start cool state. So start cool state, this is immediately going to turn on the cooling control and then immediately transition unconditionally to the cool state. So there are two types of transitions. There's the immediate transition, which is one of the command entries. And then, of course, there's the conditional transitions that can be configured. So this is going to go into the cool state. This has no commands and just waits for that pressure to get back down below 800. And in that case, it's going to transition back to the start state. We use the start state because that makes sure the controls are all off and then goes back into the hold state. So that's kind of the little triangle loop that it continually does between a hold, heat, and cool, with some intermediate steps to do the transition control logic. And then, of course, there's a stop that I don't have implemented yet in the engine. Once it's running forever. You can restart it. But yeah, still got some more features, but the logic is working, which is pretty cool. So you could specify time down to 2 decimal places with this current implementation and the 10 millisecond period being hard coded into it. But this lets you do more complex automations, and you could load and run multiple sequences in parallel. Right now, there are no checks for any competing control. I'm thinking I'm gonna leave that up to the discipline of operators, and they'll just have to be aware that if they're running a sequence that is going to compete with another sequence, to expect bad behavior. In the future, when I have editors for this, I'm just editing these JSONs by hand at the moment. In the future, when I have editors, we could be looking at all of the sequences for a test system and warn of potential issues. But ultimately, I'm going to leave that kind of logic and gating out of the software, and let people shoot themselves in the foot. Of course, they'll need some training of what things to be careful for and what to watch out for. But ultimately, my goal is to keep the software out of the way, and let operators be clever if they need to be. So this was this last week's project, and it's working really well. If I stop this and then rerun it, so everything went stale. We got the light blue everywhere. Why are you dinging at me? Okay, so we'll watch what the LabVIEW process does. So this is kind of idle, so it's loaded. It's not running. Actually, technically, it is running. It is updating this time value, and some time information is getting published around the system. There's just no state that's been activated. Oh, go away, Windows Update. There's no state that's been activated. So these sequence times and state times are just the same as the wall time. But if I do start this, there's an initial hitch on the CPU usage, but ultimately it's not too bad. Gained about another 1% CPU usage on average. But now in this front panel, we can see the sequence time and the state time climbing. And then as I get this to change states, we can see the state time resets. And if I make sure that stays visible, we can see it transition to the different states. And then the resulting commands that get run.